Good evening. We have this as lecture number 2 for DSS, revision lecture number 2 for DSS. And in this, we are interested with, already I have shown this theory part, already we have covered, and now we are interested with problems. So laterally supported beams, and we are going to solve the problems on this in this video. Now we will see which type of problems we have to solve, or which type of problems we have in unit or under this bending. So we have compression flange. Already we have seen in last video compression flange. So if this compression flange is restrained, then we have beams as laterally supported beams. Laterally supported beams. And in this, we have bending moment predominant. Bending moment predominant. Predominant. And in this, these members are known as purely flexural members, or we can say flexural members. And we are going to use in this, or we are considering VU less than or equal to 0.6 VT. Now, for this, we are going to use clause number 8.2.2, sorry, 8.2.1, and we have page number 52. This is for first part. Second part, we have compression flange is unrestrained or allowed to deform laterally, or allowed to deform laterally. This is restraint means lateral deformation is prevented. Lateral deformation is prevented. Then these are known as laterally unsupported beam. Laterally unsupported beams. So you have shear force plus bending moment. Both are considerable. And these are going to be designed for combined loading. Sorry, laterally unsupported beams. So again, we have actually, these are for flexural member only. Flexural member. Now in this, we have no VU less than or equal to or greater than or equal to. We have to go directly clause number 8.2.2, and we have page number 52. Now whatever this here I have mentioned, so this is actually here. So VU less than or equal to 0.6 VD, and now second we have VU greater than 0.6 VD, and in this we have bending moment plus shear force, both are considerable. This is A part, this is B part. The here members are designed for combined loading. Combined loading. And we have for this clause number 9.2. And from this, we have to design this section. Now, in this most important, we have VD, which is for laterally supported beams, and that we will see over here. So this is according to clause number 8.4, which is given on page 59. And you can see we have VU is equal to, you can see over here VP is Vn, and Vn upon gamma m. So we have VD equal to AV FYW upon root 3 gamma m. And AV we have given as shear area or yield strength of the web. And that we are going to calculate, that is value of AB according to your properties of the cross section. Now in this we have second part, which is most important one, that which type of problems we are going to solve in this, that we should know. So we have to go for the problems in both laterally supported or unsupported. So we have over here analysis, or we have to design the problems. Now we will see what is difference between the two. In analysis, cross section is given. Cross section given. So as cross section is given, so using annex, we are going to use annex H. Annex H. And from this annex H, which is given on page 138, for I section and channel section of IS 800-2007, we are going to know the properties of section. If given for VU and VD relation, then we have to use this. But if not given, then we have to assume VU less than or equal to 0.6 VD. And knowing this and properties, we can use clause number 8.2.1 or 8.2.2 or 9.2, and we can calculate value of MD. And knowing value of MD, we can find load. So MD we have design strength. Then knowing the beam, we are in position to calculate load. So we have formula WL/4, which is equal to MU, which is MD, if beam with concentrated load at center. Beam with concentrated load at center. And that will give us value of W, which is acting at center. Or we can have WL square by 8, which is equal to MU, equal to MD. So beam with UDL throughout this span. Throughout span. And likewise, we are in position to calculate loads. In the design, we have given loading, we have given span, support conditions. These are given. Knowing these values, we are in position to calculate value of MU. Now, knowing MU, we are in position to decide the section, and that is by using formula of 8.2.1, page 52. So we have mu is equal to md is equal to beta b zp required now fy upon gamma m. And we have to always assume beta b1, and from this we will get zp required is equal to mu gamma mo upon fy. This is given table 5. Partial safety factor, that is 1.1. And knowing this, ZP required. Now, if you have laterally unsupported beam, then this ZP required is increased from 10 to 40% for laterally unsupported. For laterally supported, we have to take as it is. Knowing ZP required, we have to select section from Annex H and write down its properties, and then find value of MD for the selected section. This MD should be greater than or equal to mu. Means whatever we have done over here, so we have to do this. Now we have now no cross section, so properties we have taken. We have to check this. VU less than or equal to, or VU greater than or equal to, and accordingly we have to use clause number 8.2.1 or 8.2.2 or 9.2, and accordingly we have to find MD value, and this MD value should be greater than or equal to MU. So likewise, we have to go for the problems. So now we will go with a simple problem. So we have determine bending strength of ISHB 450 at 72.4 kg per minute. So now as section is given, ISMB 450, as cross section is given, so we have this problem is of analysis. So now we will go with this solution. We have step 1, given data. So we have ISMB 450 at 72.4 kg per meter. Step 2, properties of section. Now we have Annex H IS 800. And we have page number 138. So we have H, or we can write D, 450 millimeter depth of section. Width of flange we have 150 millimeter. Thickness of flange we have 17.4 millimeter. TW we have 9.4 millimeter. And ZPZ of this section is 1533.36 into 10 raised to 3 millimeter. Now we have step 3, bending strength. Step 3, classification of section. So we have B by TF, table 2, page 18. IS 800 2017. B is BF by 2 upon TF. BF we have 150 by 2 divided by 17.4, 4.31 less than 9.4. Therefore, section is plastic. Section is plastic. Then we have D by TW. So we have D minus 2TF upon TW. So 450 minus 2 into 17.4 divided by 9.4. It comes 44.17 less than 84. Therefore, web is plastic. And as both are plastic, so we have section is plastic. And therefore, beta B is equal to 1. Now we have step 4, bending strength. Now as we do not know loading, so we are going to assume VU is VU less than or equal to 0.6 VD. And therefore we can use formula MD is equal to beta B ZPZ Fy upon gamma n. Beta B is 1 into 1.33.36 into 10 raised to 3, 250 upon 1.1. It comes 348.48 into 10 raised to 6 Newton millimeter, and therefore design strength equal to 348.48 kilonewton unit. So this is our answer. So today we will stop here only. The remaining part we will see in the next lecture. So thank you. So go through the problems. I already mentioned that laterally supported beams problem video in playlist. So go through it also. So thank you.